In this example, we want to use integration to find the antiderivative of f of x. Remember, f of x is our derivative function. So in order to find the antiderivative, they're asking us to find what is f capital of x equal to, all right? Such that if we take the derivative of this, we're going to get this, all right? So let's see, how do we go about doing this one? Again, it is complicated. We don't know any trigonometric rules for integration for this form, all right? We just know some basic ones. So let's say we can deconstruct this one and rewrite it in a way that we know how to integrate, all right? So start noticing that on the denominator, we have cosine square of x. So that means that that is cosine times cosine, all right? So maybe rewriting it like that will give us a little bit of a clue. All right, so we start by saying that f of x is equal to sine of x over cosine of x times cosine of x, and we can go ahead and separate this one, all right? So let's actually write our notation. We want to find what is the integral of sine of x over cosine of x times cosine of x with respect to x, all right? So let's see, we can go ahead and separate this as two fractions, all right? So this becomes the integral of 1 over cosine of x times sine over cosine. They are equivalent, all right, the x. And let's see, what is 1 over cosine? We don't know what that is in terms of integration, but we know that 1 over cosine is nothing but just secant of x, and we know the sine over cosine is tangent, so we can go ahead and rewrite this as the integral of secant of x times tangent of x with respect to x, and with respect to x, and now we know what this is. All right, now do we know anything that when we take its derivative, the derivative of it is secant x tangent x? And the answer is yes, we do. That is secant of x plus c. So what is f capital of x? It's equal to secant of x plus c.